which you have not seen, or we've not done anything like that in this. So I think it's something more like the integral from f of x minus 2 from 2 to 4 dx becomes the integral from 0 to 2 f of x dx, something like that, where you use this shift and it affects these two numbers.
Okay.
If I had to guess.
So you just subtracted the 2 from the 4. Okay.
Yeah.
I guess you
and if it was like,
yeah.
Yeah, and if it was like the integral from g of x plus 3 from 2 to 7 dx. Sorry, this is wrong. I'm shifting it the wrong way. So x minus 2 is a shift right. So let me
So it's 6 and 4.
Yeah, it was going to make it like more like what you might actually see. So it would be like it would shift it to 0 and 4. It's a shift right.
Okay.
And then I was doing here from 3. This is a shift left. So it would be from 0 to 4 g of x dx.
Okay.
You will have to flip one. So that is like if for some reason you were given from 4, I don't know, like something like that, like these are negatives of the other.
Mm-hmm. Wait, so I see. Okay.
So that's what I take the first bullet point be.
Okay.
The next one says plug in 0.
Yeah, I didn't really know what that meant, but
so here's what I think it's f. Let me not assign a variable that equals the integral from 0 to x of some function. We'll go f of t dt, like that. So yeah, so it would be something like this. If I wanted to find f of 0, that's the integral from 0 to 0 f of t dt. So that 0 goes there. So this will be given. This is like a given in the problem. Do you remember that? I don't know if it was it was a PowerPoint. It was like one of the last slides. It had a curve, some sort of curve, and it said it gave you this right up here. It said that f of x is the integral from 0 to x of this function f of t. So when it says plug in 0 to x, that's what it's referring to. It's like you're going to put 0 in, but
it could be whatever number.
Well, yeah. So like it might be from 4. It might say find f of 4, and that's the integral from 0 to 4 f of t dt.
And then you solve that like 0 to 0. Well, I guess 0 to 0.
So this one's 0. Number. This one you would find maybe it's given in the graph.
Like, what do you mean given?
Like it would tell you that this area equals 8.
Because you can't just like well, there's no like function, I guess, to solve for, right?
Right. That's the problem here. You'd have to estimate it. But I maybe the one we did was a little nicer. Like it had like nice, shapes. I don't really remember.
Okay.
But I think that's what it's referring to. Is like put this 0 into the top bound.
Okay.
And now this free response. I'm sorry. So this next one, chain rule. One that is 2x. You need to.
That's like the integral stuff, right?
I don't know what that's referring to.
Because isn't there like integral, like, or maybe it's the antiderivative?
Oh yeah. Okay. Yeah, it's the fundamental theorem of calculus part 2. So the integral from 0 to 2x of I don't know, sine of t sine of t dt. And so you, or it's d dx of this. So you take the 2x and put it in here, but then you also multiply by 2.
Okay, so that's where the,
That's the chain rule part.
I see. So just like whatever the number is in front of the variable, basically, you multiply that?
Well, it's whatever's up here. So like if I wanted you to do d dx of the integral from 0 to square root of x, t over 5 plus t squared dt. The solution to this is you take this and you put it in for t,
So
whatever
square root.
variable. So it's the square root of x over 5 plus square root of x squared. But then you multiply by the derivative of this.
Oh, it's the derivative of that. Okay. So
Yeah, that's why it's by 2. So this is the shorthand of it.
Wait, that's the derivative of root x?
Yeah, because square root of x is x to the 1/2. So its
Okay,
derivative is 1/2. And this is just a nice compact way of writing it. The applications also in it. So yeah, but it sounds like it's going to be 2x. So you don't have to do anything this sophisticated. But the point is that you end up putting the chain rule is this part that this 1 over 2 square root of x, the derivative.
Okay,
It's also there as well.
got it.
Graphs of f of x and g of x is the integral of that graph. That's kind of related to the second bullet point. But let me make a graph here to try to help here. And you did get a problem like this. We did one at some point. I don't know what it would be, but so it's like, and then here, just leave it like that for now. So this is 0, A, and B.
Okay.
And it says, and this is the graph of f of x, and g of x equals the integral from 0 to x f of x dx.
All right.
So that's why, like, it's kind of like the second bullet point, because g of 0 equals the integral from 0 to 0 f of x dx, which is 0.
0.
But if I asked you for g of a, assume a is a number. I don't know. A could be 5, 2, whatever. It's now the integral from 0 to a f of x dx. And this equals whatever the area is here. So let's say the area is 10.
So they have
Just
to give
making
you that
that up.
area?
Yeah, or you got to be able to calculate it. Like, because it's
Okay.
nice. Like maybe they say like this is a semicircle, or it's, it's some sort of a rectangle, or
Okay.
triangle thing. Okay, but then they could ask for like g of b, and g of b equals the integral from 0 to b f of x dx equals, and let's just say this area is equal to 4. This would be 0 to b includes the area from 0 to a, but it also includes this area from a to b, so it's 10 minus 4, because the area below the curve is negative.
Wait, so why is it 10 minus? Oh, because it's b to 0. I see.
Yes, yeah, you're 0 to b, because you're starting, you're going all the way.
Okay.
So that's kind of related to the second bullet point. If we were to let the graph here, and it says that f of x is the derivative of g of x. So you're looking, this is the derivative graph. And if we want to know, there's a lot of things that we could ask for here. But if we wanted to know the, Boy, see, that's where I think this is probably the wording here isn't right. Like the first question they might ask is where's the max of g of x? Like I think that's a more realistic question based on what I've seen. And g of x is the area under the curve.
Okay. So
Okay, so that area under the curve is maximized here at x equals a. Because all the area is contributing positively from 0 to a.
okay. So then the minimum would be b.
Yeah, the min of g of x is at x equals b because now you have positive area and then negative area, cutting away, taking away from it.
Okay.
Now, if you go back to like, if you didn't know any of the second semester of your calculus class, and I just gave you a derivative graph where the derivative crosses is either a min or a max.
Where what?
Where the crosses the x-axis is either a min or a max.
Yeah.
Yeah. So what that means is that it's the graph is going from increasing to decreasing. The original graph, so it's going from increasing to decreasing. That's a max.
Oh, it's a max. Yeah.
Yeah. Right. Okay, so that's one thing I could be asked. Now,
But that's like not like at a though. That's like in between 0 and a.
No. This is the derivative, even though it's written as f of x. Like don't think about it. Think of this as g prime of x. If I give you the derivative, where the derivative crosses 0 is a min or a max, always of the original function.
I see. Okay, gotcha.
And that's why it's consistent with this answer here. It's just done a different way.
Okay.
Okay. Now, the next question says the area from -2 to -6.
I think
If you're moving to the right.
I don't think like the values are right. I feel like they were maybe just giving an example, but I don't
Yeah.
think
So it's like saying this: the integral from a to b, f of x dx is equal to -4 because it's going left, left to right, like that.
because it's like
So-
under
so-
the x-axis, right?
Right. But if I flip the limits and I say from b to a, f of x dx, it's now +4.
Okay.
And I think that's what the second sub bullet point is trying to remind you.
Okay.
The last one is, I think, probably the hardest because it says point of inflection. So points of inflection from it's of g of x, and you're given the derivative graph. So points of inflection occur where there's either a min or a max. So let's call this point D and this point E. So D is a point of inflection because the derivative is increasing and then now it's decreasing. And E because it went from decreasing to increasing.
So wait, increasing. So where's the point of inflection?
It's at D. D and E are inflection points.
Oh,
because you're looking at,
increasing or decreasing. But then that one, A to B, it's decreasing to increase. Okay, yes, I see that.
all right. So I think that's kind of I think that'll be the most confusing because you're moving between derivatives and then the derivative of the derivative and the integrals. Yeah.
Okay.
All right. So the next section, it sounds like you can use your calculator for almost everything, but I think that, remember that we were having that discussion last night about like, if I wanted you to find the integral from 0 to 3 of 4 minus x squared dx, that depending on the way this is written, you may or may not, you graph here, it starts at 4, it comes down, but then it goes down there. And like you could, like the correct answer depends on whether you want to, like, this is positive contribution and this is negative contribution.
Right. I remember that.
And so like if it asks for the integral absolute value 4 minus x squared, I'm not really sure how this would be asked. But like these produce different results. You know, the one on the bottom here, this part contributes positively for it. So it might say something like total distance, and that's this one. Total displacement is the one up here.
Okay, so, but what's the difference between the displacement and the distance again? I don't.
Yeah, so I'm going to go back to kind of our track example. So if you go all the way around the track, your distance is 400 meters.
Okay.
Okay, but your displacement is 0. Exactly where you started.
Okay.
So if you want the total distance of something, you have to basically all areas are considered positive.
Oh, okay.
And total displacement, you have positive and negative areas.
Okay. Got it.
And so I guess I would think, okay, that's that's kind of your what this refers to when it says like, yeah, you can do them all with a calculator, but you may want to break it up. We did some of those piecewise graphs yesterday that
Okay.
where
Well,
you
I
gotta
think
know where
also
it crosses.
the one, like, yeah, like we did one yesterday, I think, when it was like we had to do like 0 to 3 and then 3 to 4, right? With the
Yes.
like
Yeah,
interval.
something like that.
I think maybe that is also a possibility.
Possible. We're going like where there's limiting kind of returns here. I don't know.
Yeah. But can we do one of those? Like, I feel like it could
Oh,
be
sure.
helpful.
So like a piecewise kind of thing.
Yeah. Like
Like if I asked you
what was the thing we did last night? I don't know. You probably don't remember. But it was like we had to like break it up into 2 and then like add them together.
Yeah, so if I give you a piecewise function, like let's say f of x equals absolute value for minus x, and that's good from -2 to 1, and then x squared plus 5, so x less than 1, from 1 less than or equal to x less than or equal to 2. And like this looks like you can solve, you can just use your calculator to do it.
Mm-hmm. But well, so using your calculator, you would have to like make up the integrals though.
Yeah, so you're like if you want, like if you can, I would just go to your calculator and go integral -2 to 1 absolute value for minus x dx. That'll
Okay.
give you a number. Plus, and then you have to do the other one. You have to, integral x squared plus 5 from 1 to 2.
And then you just add those together.
Yes.
Like
but like the way go ahead.
no, you go ahead.
It's just it's kind of it's suggesting that you're gonna.
Well, like
I don't know, let me read it again. Go ahead.
What I was
Yeah.
thinking is that it would be like something like I don't know. This is probably wrong what I'm saying, but like 0 to 4, and then you have to break it up like from like the integral from 0 to 3, whatever, plus the integral from 3 to 4 of whatever. Because like, didn't we do something?
That's why like if you were to just make this kind of simple, like x -2 from 0 to 4, the graph of this looks like this. So there's, two regions here.
Right.
So if you were to just straight integrate this, it would be 0, but because they just cancel out. But if you wanted the total area, like, I don't know, like, I feel like that's how it's somehow going to be encoded in what the
Area.
instructor says in the question. Total area. Well, then you got to integrate this from 0 to 2, x minus 2, and you get -2, and you got to be like, oh, that's really 2. And then you got to integrate it from 2 to 4, x minus 2, which is 2. So you're good with that. So
you're
your cheat.
Are you just doing,
Yeah.
to find the integrals, you're just doing like 1/2 times whatever, times whatever?
No, your calculator will actually do this. Like your calculator. I'm just using a simple example where your calculator tells you.
Oh, you just do it. Okay.
This is fn int. Yeah, this is fn int.
And you just know to make it like a positive number?
Yeah, because the question says total area.
Oh, because it can't be like a negative area.
Right. Like somehow that's in there in the problem. But the cheat, and I don't really like that word, but the cheat is that you always integrate the absolute value of whatever it is that you're.
I see. Okay.
And then it, like,
And then
students sometimes come to me and they just want the answer, right? And like, I don't do these by hand. I go to calculators and I just do the absolute value of it and it's done. So that's, but when you're learning this for the first time, you're trying to, somehow the question will be asked like total displacement to, I think, kind of express that.
Okay. All right.
Now, has your instructor given you any AP free response questions yet?
There was some in the book. Did we already do the write an expression and solve for it, that thing?
I have no idea what that is. I mean,
Okay.
that sounds like a...
Yeah, he did. Well, I mean, we had some in the book for the review. But yeah.
So I grabbed, like, I did a search because I know this is a really common thing that they give you, and this is a trapezoidal question.
Oh, and I know also that there will be something with like a particle on the test, like particle motion.
So I know this is something we want to cover, so we'll just do this real quick, and then we can talk about particle motion.
Okay, yeah, no, that's fine.
Remember I mentioned like sometimes the gap between these aren't the same.
Yeah, different widths, right?
Yeah. So the question is like, how are you going to, and I don't know, like, see, that's where I think like your instructor's probably going to grab something like this to get you familiar with this style of question. So the problem is these have different widths each time, and you have to account for that when you're doing the problem. Did you see anything like that up until like that? Is this the first time you're seeing something with different widths? Anything in the classroom?
No, I think we saw some in class with different widths. Okay.
So if you remember the area of a trapezoid, okay, like think of it like, actually that's a really bad drawing for the first one. The first one is okay, this is 66 and this is 60. Okay, and this is 0 and this is 2. And then 5 is even further down. We'll go, that's 5 and that's 52. And then there's yet another one here, 9 and 44. And then there's a last one here at 10 and 43. So these are the heights. Okay. So how would you find the area of this first one? Well, you would remember that the area of a is 1/2 base 1 plus base 2 times the height. The height, though, this is the awkwardness, is the height is actually this distance here along the base, along the base here.
Yeah. And
so that's why it's a little,
Isn't it written as
Go
like h over 2 also? Like-
Yes. Yeah. So it's h over 2 b1 plus b2. So each of these is the following. So it's like 2 minus 0 for the first one. That's your h over 2 times 66 plus 60. That takes care of this first one.
Okay.
Plus, what's the width of the next one? It's 5 minus 2 over 2 times, and then it's the average of these. Well, not the average, you have to just add them up.
Yeah.
Yep, so that takes you to the next one.
And then
Plus
4 over 2.
9 minus, yep, 4 over 2, good.
50.
And then you got to add up 52, 44. Okay. And then the last one is 10 minus 9 over 2.
44 and 43.
44 plus 43. So what you notice, I don't know if you can see this here. Do you see how 60 is used twice and 52 is used twice? That's where that twice comes in, but the endpoints are only used once.
Oh, that's the 2 times what I see.
Right. This is not that we were using before is for like really nice ones, but on the AP, which I don't know that you're taking, but if it's in this, if you get an exam like this, they're not equally spaced, you can use this way.
Okay, sorry, you're cutting out a little bit. So if I
apologize. Is the quality of this not very good tonight?
No, the video is fine, just the sound.
Okay. All right. Do you want us to look at another one of these or move on to?
So for this, like, could you do it in the way with like the trapezoidal, like where you just do like 2, like how would you do it with like the actual like?
You can't because widths.
Oh, so it has to have the same width.
If
that? Okay.
Yes, and that's why I mentioned that a few times, and like it's awkward when you see it for the first time. You're like,
can we do it when with the same widths?
As a table or as a function?
Whatever.
Okay, let's do it with it. So I want to find the integral of 1 over x from 1 to 5 dx and n equals 4.
Okay.
So I think you said it's like h over 2. H is always b minus a over n.
So h is in this case 5 minus 1 over 4. 4 over 4, 1. So 1/2 times.
Yes, your t 1/2 times, and then it's I like to actually write it out like this: f of 1 plus 2 times f of 2,
Okay.
because these are increasing by delta x or
And we go to
h.
4, right?
You actually go all the way on this one because it's got to include the endpoints.
Oh, okay.
That's the difference here, and these are each delta x apart. What you're thinking of is left sum or LRAM, RRAM. They only use left or right.
Like however many like boxes, that's the
Yes.
one, right? Okay.
Yeah. So the
So
trapezoid
then-
uses all.
So this is like 1 over 1, right? Plus
Plus 2 times.
2 times 1 over 2 plus 2 times 1 over 3 plus 2 times 1 over 4 plus 1 over 5. So then that's 1/2, 1 plus 1 plus 2/3 plus 2/4, 1/2 plus 1/5.
So I
So
would look at these last 3 and make a common denominator that you can apply to everything. So it looks like it's 30.
30. Okay, so that becomes times 10, so 20 over 30. 15 plus 15 over 30. 6. So then that's 35, 41 thirds.
But you got the 1 and the 1 to
30.
account for.
Oh,
So that's
wait,
like 101 over 30, but then you got this half to bring down.
41. Okay, wait. And then that's is okay, wait. 41. Okay, yeah. 101. Okay. So then that's the final answer.
That's it.
Okay. Not too bad.
Okay, so you mentioned something about particle motion.
Yeah, I don't really know what it would be, but I just remember.
So like the first thing that comes to mind here is that they give you velocity as a function of time. And they tell you that you know you're going, make this nice, I guess, like this. And then you're going like this. Something like this. And this is V of t. And they might tell you that S of t is the integral from 0 to t V of t dt. So what
Okay.
this means is that like you could think of this as S prime of t, because it is the derivative. V of t is the derivative of that. So they could say, okay, well, we've kind of already asked this, but it would say like, how far has the particle traveled? Or actually, what is the total distance traveled?
Okay.
So total distance traveled, that's the scenario where all the areas are positive.
Yeah, I was just gonna say it has to be positive, right?
Yeah, because I think you'll find that you end up getting more negative area than positive area on this one.
So then you just do like 0 to, what is that? 1, 2, 3, 4. The integral from
Yeah.
0 to 4.
Right. So it's the integral from 0 to 4 V of t dt.
And then from
But then you
4
subtract
4 to
to 9.
5. Yeah.
V of t dt. Yeah.
So then you do like, you just, oh, you
So
could
the
do areas
area
like,
of this one, 1/2 base times height. This is base 4 and height 3.
oh, so you have to do too many triangles.
Just one here. You can do one triangle here. The area of this is 6.
Wait, but what? Isn't that's, I thought you can only,
Remember the height is right there.
oh, okay.
4 times 3 and then cut it in half. And then for the trapezoid, you take your base 1, which is 5, base 2, which is 2, so that's 7. You cut that in half, 3.5, and then you multiply it by the height, which is 3. So this is an area of 10.5.
Wait, can you write the trapezoid one out? Because I always get confused with those.
Yes. Trap is 1/2 base 1 plus base 2 times the height.
So in this case, it's 1/2.
5 plus 2.
Where's the, oh, the other side, I see.
And then the height is 3.
Because it's down 3. Okay.
Yes. Yes.
So 6 minus 10.5, but you make it positive.
Yeah, it's really like that. Yeah.
Yeah.
So then the next question that could be asked.
What? It's not 6. Wouldn't it be like positive 4.5? Because don't you do like that?
No, like it's like your car went forward and then you we're in reverse for some reason.
Oh, but you're still
driving
checking.
around for
Okay,
a little
gotcha.
ways. Yeah, so then the other question is what is the total displacement? That's not usually how it's asked. But I'll write that first. What is the total displacement? How it's normally asked to say how far is the particle from its starting position? That's the same question. So these are both asking about total displacement. So this is where you subtract the negative areas, or you subtract the area that's below the x-axis. So it's negative 4.5.
Okay, gotcha. All right.
Ask things like, let me grab this graph again because that's what we're looking at. We ask things about the acceleration. Okay, we could say, when is the actually the particle not moving?
Oh, okay, so that is
It's when its velocity is 0. Remember, this is the velocity in time graph.
I see. Okay. So t equals
So-
0, top 4, and
Yeah.
what is the other one? Like the oh, its acceleration is 0 or whatever.
Yeah.
Would that be like the point when it's like flat to like negative
So
3?
the acceleration is 0 here. from
Yeah,
here to here.
negative 3, right? Oh, so negative.
Well,
No, t
from t equals 5
to
to t equals 7.
7. I see. Okay.
Yes, yes. So the other question is, when is the particle moving right? So right means that the velocity is greater than 0.
So 0 to 4.
Yep.
And
And then it could ask that, and that's it, because all the other ones are negative here. When is the particle moving left?
4 to 9.
Yeah.
What's the other one? The like when is it positive, right? Is that the other one?
It could ask when it's speeding up or
Speeding
slowing down,
up.
but that doesn't seem to happen. Yeah. So it's speeding up here in this first part because its velocity is positive and an acceleration is positive.
Yeah, and then
And
isn't
then
it like
it's
yeah, right
it's here
there.
because the velocity is negative and the acceleration is negative.
Right, and then the other ones are slowing down on the other two variables.
Yes, yes,
Okay.
exactly.
All right. That's kind of all I had. We can do just whatever now.
Okay, let's do just some problems here based on what I think maybe could be unclear for you. So let's say let's say f of t equals the integral from 0 to x t plus 3 dt. Okay, and I want you to find f of 0.
Okay. Oh, so you plug in 0 for x, 0 to 0. T plus, is it just 0?
Yes. Okay, so now we're gonna make it more difficult. What is f of 1?
1, 2, 3. Oops, no. 0 to 1. dt.
So here's your hint,
Oh, wait,
anti-derivatives.
Wait, if it's f of t, why why did I plug in a 0 for x?
All right, sorry, f of x. Yeah, that's my mistake.
So then should it be x plus 3, not t plus 3?
No, the variable doesn't matter.
Oh, I see.
If you prefer treating it as an x, you can. But
Okay.
thank you. You caught me on that. It was written wrong,
Okay,
which is bad.
derivatives. So that is t squared over 2, right? Plus
Yep.
3x.
3t.
Oh, yeah. T. At 1 and 0. Okay, so then you do 1 over 2 or plus 3 minus, and then it's a 0, so nothing. So 3.5.
Yes.
3 halves.
All right, so let's go back and grab this. Okay, so the questions could say something like, what is f of 3 minus f of 2? And what does this represent? Actually, let me do f of 1 because you already have that one.
What is
You already
f
found
of 3 minus f of 1?
Yes, and you already found f of 1. That was
Okay, so you just
from
plug in 3. Okay, so 3, 0, 3 plus t plus 3. It's the same. Oh, so it's the same antiderivative.
Yep. Same antiderivative.
2 plus 3t 3, 0. So 9 over 2 plus 9 minus 0. So then common denominator, gotta multiply by 2. So 18 plus 9 is 27 over 2 minus 7 over 2. So 20 over 2, which is 10. What does this represent?
Yes. Okay, so let me write it out here before I let you get much further so you can see. Okay, so this is what you just did.
Right.
And typically here's what you just did. The graph doesn't matter, but I guess for this one we could make it kind of nice. So t plus 3 from 0 to 3 looks like this. That's the area you just found. And then from 0 to 1, it's like that. So if you subtract out the area, what's left over? So this one's in red.
The trapezoid? I don't know.
Yes, it's trapezoid. It's the integral from 2 to 3.
Oh.
And that's what they're looking for here. Is
Okay.
it's actually the area from 2 to 3.
Okay.
All right, so let's do another one here. Let's ask you to find the integral from 1 to 4 square root of x dx.
1 to 4 square root x dx. So you do antiderivatives, right?
Yes.
Okay, so that's x 1 plus 1. So then that's 3. It's x to the 3 halves over 3 halves over no.
Yep.
Is that right?
Yep.
Oh, okay, cool.
Yep.
At 4 and 1. So then it's 4 to the 3 halves over 3 halves minus 1 to anything is just 1. So minus 1 over 3 halves. How do you do 4 to the 3 halves?
Yeah, so 4 is really 2 squared. And then you multiply the exponents. So that becomes 2 to the third. 2 over
Okay,
1 times
so
3
you
halves is
multiply 6 and then over 2.
6, yeah.
3.
Yes.
2/3. 2 to the third, 8. Minus 2/3. So then that's wait, so you do 2/3 times 8. You have to make common denominator, right? No,
That's
you're not
16
adding.
thirds. Yep, not yet.
16/3
Yes.
minus, okay, so then it's 14, yeah.
All right, so so which are an overestimate for n equals 2. Well, I'm not going to write this. So I want you to integral 1 over x dx from 1 to 2. But I basically just wanted you to see, like, do you remember what the graph of this looks like?
For 1 over x?
Yeah. Remember that it looks like this.
I think so, yeah.
Okay, so the L sum is an overestimate.
Oh, right. And then if the other one was like, what is it if it's going like pretty much like flipped? Like, what would the
Like
function be
this?
for that? Yeah,
So
that's x squared.
this is like a root x, but it's an
Okay.
underestimate.
Right.
So just if you've got a calculator, you can draw these if you want, but
Okay.
you should just maybe think about that. That seemed to come up a few times.
Yeah, that was on the quiz, so I'll look at that again.
All right, well, that takes us to the end of our lesson today. We'll see you next time. Good luck on your test.
Thank you so much.
Have a great day. Bye now.
Bye, thanks.